Welcome back to the deep dive. Today we're putting on our engineering hats.
We
We're
are.
looking past all the marketing fluff and right into the specs of a really specific piece of hardware. It's the PureLink OLC II DVI to fiber extension system.
Right. And our goal here is to figure out what this gear tells us about solving these, massive problems with distance and quality in professional video.
Exact.
At its core, this thing is all about a fundamental constraint. Copper cables, they just can't handle high bandwidth signals over long distances. They degrade.
So this system, with its transmitter and receiver, it moves that signal onto fiber optic cable instead.
Precisely. A DVI 1.0 compliant signal. And DVI 1.0 is interesting because, it's not the absolute newest standard, but it's chosen for being incredibly robust. It's about zero signal loss.
Okay, so let's unpack that. When you go from copper to fiber, the distances, they just explode.
Yeah.
How far can this thing actually push a full 1080p signal with, like you said, zero loss?
This is where the engineering really shines. But it all, and I mean all, depends on the type of glass you choose.
The fiber itself.
The fiber itself, if you're using single mode fiber, the long haul stuff, you can push that signal up to just a staggering 6,600 feet.
Wow. That's what, 2 kilometers?
2,000 meters, yeah. Now, compare that to multi-mode fiber, which is for shorter runs inside a building, maybe. That drops to 1,650 feet. Still impressive, but a big difference.
But either way, you're getting a perfect 1920 by 1200 signal over a distance where copper would have just completely given up.
Failed entirely.
So that distance, though, it brings up another problem, doesn't it? The source, like a computer, it needs to talk to the display. That digital handshake often just collapses over long runs.
Ah, yes. And this is the really clever bit. The spec sheet points to virtual DDC and auto ED programming.
Okay, so DDC is the display data channel.
And ED is basically the display's ID card. It tells the source what it is and what it can handle.
Right, and over a long copper cable, the source asks for that ID card, and the response just gets lost in the noise.
Exactly.
Yeah.
This system sidesteps that completely. It digitally stores that ED diode info right there in the transmitter module.
So the source thinks it's plugged directly into the display.
It does. The handshake is instant and stable, and it doesn't matter that there's 2 kilometers of fiber in between. It's a really elegant solution.
And when you can run signals that far, that reliably, it immediately makes you think of environments where, failure is just not an option.
It has to. And let's not forget, fiber is inherently secure. You can't really tap into it, and it's totally immune to electronic interference.
So places like government, military.
Government, military command centers, even sterile medical environments where you need perfect, secure imaging. It's the ideal choice.
And the physical design seems built for that. I'm thinking about the nightmare of trying to pull thick copper cables through, like a hospital wall.
Oh, absolutely. They're designed to be almost invisible. The transmitter and receiver modules are tiny. They're housed in these compact little DVI enclosures.
How small are we talking?
Just 1.5 inches wide by about half an inch high. Tiny. And they use these small LC fiber connectors. So the fiber cable itself can be run through conduits you could never get a DVI cable through.
And that lean design ethos carries over to power, I assume?
It does. The whole system consumes only 1 watt of power. Just 1. It barely needs anything.
So when we boil it all down for you, the listener, what does this really mean?
I think what it means is you have a system that makes a very specific trade-off. It prioritizes that DVI 1.0 reliability and incredible distance.
Over 2 miles, yeah. All while giving you that superior security and just amazing flexibility because it's so small and efficient.
And that leaves a really interesting question for you to think about. You see that wide operational temperature range in the specs, from freezing right up to 117 degrees Fahrenheit.
Right, plus that minimal 1-watt power draw.
So when you see that kind of rugged, efficient design, you have to ask yourself, how is this changing where we can actually place high-demand video? We're moving it out of the clean server room and into much more challenging remote environments, aren't we?